rotating, you can hear 100% infill. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm cube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey everyone, One Raz, Rob Eng, 954. How is everyone doing? Are you guys ready for another episode of PRINTBUSTERS? Today we're gonna have a look at calibration. So I hope that's gonna be some nice new stuff. There's two. I actually just discovered one link that I missed on Discord that was shared by TR Chen 1033. So he said this is kind of the Bible of calibration for the Voron community. So I really hope there is some interesting calibration information on that link. And then I saw a video yesterday that was released by Vector 3D on their calibration flower, on some updated stuff about the calibration flower. And I've never taken a look at what is this calibration system. So on his video, he clearly says stop using calibration cube. So I guess he thinks that calibration cube are not good enough, or they are not doing the job, and so he designed something else that is called the calibration flower, the Califlower. So we're gonna have a look at it and see, why he designed it this way and whether it is really working or not. But before that, let me start our usual giveaway. So let me put that in. And let's bring some awesomeness here. So it's PRINTBUSTERS episode 7, and I'm awesome. Perfect. And then let me put the banner in there. Where's the banner? There you go. Okay, great. Firelight, thank you for joining the stream. Sleep Peeking, thank you for joining as well. So there you go. So we started the giveaway, so that should be good now. We can bring some awesomeness here. FDAF Patch, I'm here. Thank you for joining as well. I was just before I was watching a stream on designing on what? On SolidWorks, and it's been a long time. I haven't used SolidWorks, so it was nice seeing that software again. Nathan CRS1, thank you guys for joining this new episode of PRINTBUSTERS. So we're gonna start. I'm not too sure whether we start by this guide that was shared on Discord. It is a very popular guide in the Voron community. Some of us, maybe just me, refer it to the Bible and call the author Master Ellis, half jokingly. Yeah, so Master Ellis has made a guide on how to calibrate your printer. So we can. So there is this that I want to look at, and this video that is stop using the calibration cube, basically. So let me think. Maybe let me think a little bit. What? Well, it's funny because one of the topic would be stop using calibration cube, and the other topic would be print a calibration cube. So maybe let's start by the video then. let's start by stop using calibration cube, and then we're gonna check the guy that recommend to use a calibration cube to calibrate your printer and see and see how it goes. I think the main principle at play with the Califlower is that variances are better measured over longer distances. Yeah, let's see. I'm not too sure. I do see that that the STL is much bigger, and there is, yeah, it's a very particular design, but I'm not too sure why he designed it this way. So let's have a look.
How accurate is your 3D printer? It's an important question, especially if the parts you print need to fit with other real objects and align just right.
Because Sam, like
many people
what
have
needs
tried
to
to
be
come up with
calibrated?
different clearance tests and calibration cubes and other sorts of models to try and do this, but in my opinion, it will come up just a little bit short. So I decided to put my skills to the test and have a crack at it myself. The design I've come up with did significantly improve my print accuracy.
And another thing is, I still don't know what skew means. So we're gonna, hopefully he explained that in the video. If not, then we're gonna
it can
check
do the same for you too. Probably the most popular object for calibrating your print accuracy is the good old calibration cube.
Yeah, so
There are
everyone is
many
printing
different
that
variations
calibration
on
cube,
this,
right?
but typically it's your standard 6-sided cube, about 20 to 30 millimeters along each edge, with X, Y, and Z markings on each of the faces, and probably a logo on one side. But just because it's popular doesn't mean it's perfect. So let me point out a couple of things that I see as opportunities for improvement. Firstly, the size of the measurement you take will determine the amount of error in that measurement. For example, if you're using a ruler with 1 millimeter increments and measure a small cube at 9 millimeters, that's actually 10, you've got an error of around 10%, which is quite a lot. However, if you use the same tool, but the cube is 100 millimeters and you read it as 99, the error now is only 1%. Same tool, same principle, same skills, just a larger measurement.
Okay, so that was
Secondly, measuring
CRS1
outside dimensions
was
only
saying.
just isn't enough. I say this because when we measure like that, we don't make any accommodation for errors in the line width, which can be affected by things like filament tolerance and extrusion
Hey, come out on
ratio.
PLA. I saw
If
you
you
on a
like to
different stream
underextrude
just
your
before.
prints, for example, by like 5% for aesthetic quality, and then you calibrate your printer at this setting, then you'll probably measure it as fractionally undersized and change the steps per millimeter to increase the size.
So what is funny here is, okay, so the calibration here is about the extrusion, right? So it's very clear. So if it's a 20 centimeter cube, 20 millimeter cube, and then it measures at a lower than 20, then it's about under extruding. It has nothing to do with the fact that the hot end hasn't moved to the right position. So he's really talking about extrusion here more than. So that was one of my questions. Is the Califlower the design for flow calibration, or is that designed to somehow calibrate your X, Y, and Z? So it seems like it's going to be for flow calibration. So right on our topic.
Problem is, when you do a larger print, it's going to come out too large. What we need to find is the center point of the extrusion line and base our measurements on that.
SolidWorks stream.
And you guessed it, the only way to do that is internal and external dimensions. Thirdly, with a single dimension, we also don't have any understanding of any stretching or shrinkage that could occur when, like, cooling, for example. So the way we account for this, a little bit better than we have been at least, is by taking two measurements at two separate sizes. When we do that, we understand if the dimension is proportional to the size, and thus if it can be compensated for with scaling, or if it's like just a line width error. Fourth, while X, Y, and Z letters on the faces is a pretty good idea in general to let you know the orientation the object was in when it was printed, putting symbols that could introduce small bumps or uneven surfaces on those critical measurement faces will modify the accuracy of your measurement. So by keeping the measurement faces clear of other features, we should be able to reduce that error. Fifth, we have skew. Skew is a measurement of how far apart two axes are from being perpendicular. So, for example, your x and y axis should always move perfectly at 90 degrees to each other. This means that when making a right angle shape or any other angle, it will come out at what it should be.
Oh, great. Then there you go.
Assembly error, though, often means
so the skew is basically the difference between... Oh, no. Sorry. The skew is... Yeah. The difference between 90 degree and the actual angle between your x and y. Okay. Yeah, that's pretty easy to understand. CRS1, skew is the difference between a true square and a parallelogram or rhombus to the extreme. Okay. Yeah. Now I understand what skew means. Yeah, I've never thought about this actually for 3D printer. Like, I thought about the calibrating your flow and then making sure that you are going to the right. If you say 10 millimeter on the X and then 10 millimeter on the Y, then it goes 10 and 10, and then same for the Z axis. But I've never thought about the skew actually. So that's a very good point.
Your axis on 90 degrees, but if you try hard enough, maybe you manage like 89.8. The problem is, even 0.2 degrees when measured over a 300 millimeter bed is an error of over 1 millimeter. If you have holes that need to be perfectly aligned to a real object that turn out 1 millimeter out of place, that's probably going to cause issues, especially if you rotate the print next time and the skew acts in a different orientation. Skew is important, so we shouldn't overlook it.
Okay, so the problem with the calibration cube. Number one is too small. So when it's too small, then the error accuracy is too large. Problem number two, internal external dimension.
Make any accommodation for errors in the line width, which can be affected by things like filament tolerance and extrusion ratio. If you like to under extrude your prints, for example, by like 5% for aesthetic quality and measurement. Secondly, measuring outside dimensions only just isn't enough. I say this because when we measure like that, we don't make any accommodation for errors in the line width, which can be affected by things like filament tolerance and...
Okay, so the second problem is with the calibration cube, you can only measure the external dimension. So, okay, understood. And then the
external dimension.
Shrinkage.
Thirdly, with a single dimension, we also don't have any understanding of any stretching or shrinkage that could occur when, like, cooling, for example.
Okay, this, I'm not too sure how you can solve that with the calibration flower, but let's see. So the other point is, apparently there is some shrinkage going on when you print, and the calibration cube, apparently it's not good to define whether there will be some shrinkage or not, which I have difficulties to understand, but let's see. And then the last point is, the second last is the text that they put on it. It's not a very good idea to put a text on the actual surface that you are going to measure. So I kind of understand this. I mean, the best would be a really just a cube, right, without any writing on it. So I understand that. And then the last one is the skew, except having an angle measure for your cube, then there's no way to measure the skew. So I kind of understand his issue with, so it's not really issues, it's limitation. So it seems that he thinks that the calibration cube is able to calibrate your printer, but it's not accurate enough. And then he wanted a different model that would give you more information in order to accurately calibrate your printer. So let's have a look at the solution then.
So what's the solution? Well, of course, that's what I've been working on. It looks like this, and I call it the calibration flower because it's...
Yeah, maybe a larger cube can also help, John.
When printed, it provides a maximum measurement size of 100 millimeters, internal and external measuring faces, 50 and 100 millimeter measurement sizes, totally clear faces for accurate reading, diagonal measurements for calibrating skew, and of course an accompanying spreadsheet calculator to help you get the best results with minimal effort. There's also a written guide provided with the STL too. First step, once you've got it, is obviously printing. Well, some tests tell you to have like special.
Is Zombie here? Yeah, Zombie, do you have? Because I thought I could have access to the guide in order to, to get into the different explanation, but it seems like if you go, I cannot find the guide, so I guess you have to purchase, and then the STL is going to come in a compressed folder, and then inside there will be the STL plus the guide. So is the guide something that can be shared, or it cannot be shared? I have to buy the whole models to get the guide with it, or is the because I cannot find the guide, or maybe you buy it. Okay. Yeah, so I don't have the guide, so hopefully he is explaining most of it in the video.
First step, once you've got it, is obviously printing. Well, some tests tell you to have like special settings for printing calibration objects. I think that's a bit daft, because that's not how your real designs are being printed. Instead, just use whatever your normal settings are that you always use, and then you know what to expect when your final design is printed using the same settings. For the filament, it's worth repeating with each different type of filament you use, as they do have slightly different properties.
Okay, so it seems that this calibration is per filament and then per printer, I assume.
The print orientation, there's no need to scale it, size it, rotate it, or flip it or anything. Just drop it into your slicer, it'll go exactly where you need. There are two little arrows on the top face, and these are your positive X and positive Y directions, so you know the orient.
And you have to note that he still hasn't talked about E-step or anything, right? So, which I like, because in one way, like we said on the flow calibration topic, right, already, E-step or flow calibration on your slicer is the same. So I'm kind of thinking he also thinks the same, so we don't really care about E-step. So I don't know if in the guide he's talking about it, but the fact that he's not mentioning it, then it means, we don't care about E-step. Anyway, you are going to calibrate your flow.
Orientation in which it was printed. Once printing is finished, try to avoid moving it while still warm. Leave it to cool so you don't have any chance of deforming it or damaging it when removing from the bed, because obviously this will affect your results. Then you need to measure. Digital vernier or dial gauge calipers are ideal, as these are quick to use and allow for internal and external measurement. Use the best pair of calipers you have, as accuracy here is the name of the game. Here are all the locations you need to measure. Measure from the face adjacent to each number to the face adjacent to the same number on the opposite side. Every dimension will be around 50 millimeters or 100 millimeters. If they are more than 2 to 3 millimeters different, then you're probably measuring in the wrong location. When taking measurements, remove and reposition the calipers 3 times and take 3 readings.
Okay.
Type each reading into the corresponding box on the calculator, and it will then calculate the average for you. Repeat this process for each of the 10 positions. This is 30 readings, so quite a few, but trust me, it's worth it. The calculator then processes this data and identifies the percentage error on X and Y, and also the amount of skew and the correction factor that you need to make.
Okay, so let me think. What does this error means? 0.59%. What does that mean? So if it's 100 millimeter, then yeah, I don't understand what this.
Below this part of the calculator, there are dynamic text fields, which can be copied into either your Marlin firmware or Clipper config file to implement the skew correction factors that are specific to what you've just printed. If the measurements on X and Y are more than 1 millimeter away from the target, then your steps per millimeter is probably incorrect. But if your dimensions are close, then the XY shrinkage in your slicer is a great place to implement varied expansion rates for different filaments.
The XY shrinkage? Filament property. Okay, let me open my slicer. Why do they have shrinkage? Let me open super. Was it Super Slicer or was it Prusa Slicer he was using? I don't know, because it looked the same. But let me open Super Slicer, because It has the same as Prusa slicer anyway. So let's check what is this this shrinkage stuff. Let me share again. Filament setting, cooling. Where he was? Where was he? Filament setting. Filament setting. Filament setting. Expert. Okay, shrinkage. So what is this shrinkage stuff? Filament properties, filament type, PLA, PT, blah, blah, blah. Soluble material, okay. Shrinkage. Okay, either enter the shrinkage percentage that the filament will get after cooling. 94% if you measure 94 millimeter instead of 100 millimeter. The part will be scaled in XY to compensate. Only the filament used for the perimeter is taken into account. Be sure to allow space between objects as this compensation is done after the checks. Default value is 100. Parameter name filament shrink. But what? If you print that, wait, that doesn't make sense to me. That completely doesn't make sense. Let me open my my PPT. Shrinkage. Okay, so let's go. Like basically, what they are saying is this. What they are saying is, you're printing a cube, right? And then U cube is 100 millimeter. Okay, you're printing this. And then if you print a cube, and let's check. Yeah, and then you measure 94 millimeter. Then what they say is because your part has shrinked, right? So now you end up with you know what? Let me put it inside. Okay, so you printed a 100 millimeter cube, but somehow it has shrinked. How is that even possible? I mean, can you even have the filament moving from the bed? I mean, it stick to the bed. How do you want the filament to shrink? That's impossible. If it's 94 millimeter, then it means the nozzle only went until here. It didn't went all the way here. The nozzle cannot go all the way here. And by some kind of magic, then the filament move from your bed from here to there. I like the flower because it looks cool after you print it. 100 millimeter, yeah. So the fact that it's bigger, I understand. It's, you know, for calibration, the bigger the better, kind of, because the bigger the error. So you will find out the more accurate the error because it's bigger. So this I understand. That's the whole point of this. Anyone can design a 100 millimeter model and have done, okay. This assume the E step is correct. Yeah, but then now the question is, what is correct for an E step? Because I think he doesn't care. I think he doesn't care about the E step. Because he even said it. If it's more than 1 millimeter, then he said, well, actually he said the E step might be off. But again, what does that mean? The E step is off. Also, flow adjustment does not affect retraction and pressure advance setting. Yeah. This we already talked about that one. He's charging for his Califlower. Yeah, you can do only 1 point per instead of 3 to speed it up. Okay. Yeah, I think it's super slicer or Prusa slicer, one or the other. Shrinkage scales the model up instead of having to manually make it 105%. Yeah, but that doesn't make sense for me to shrink a model. That really doesn't make sense. I need to do 99.9 for PLA, 99.6 for ABS. Okay, see you, Zombie. I can see minor shrinkage of less than 1%, but any more than that, and I would check your step first. But shrinkage doesn't make sense. I mean, think about it. If you print a line on your bed and then you print another line on your bed, right? Like this. Let me put my line bigger. Or you have to help me understand. And then how can your line move? Like your line is on the printer. That's it. It cannot move. You cannot print a line 100 millimeter away from each other on when you print your first layer, and then by some kind of magic, your line is going to somehow move a little bit on the inside and to suddenly be 94 millimeter away from each other. You know what I mean? That doesn't make sense. It cannot move. ABS is usually print at 1.05 scaling. But why? Like what? How do you answer this? You print a line on the print bed, and then by some magic it moves. How can it move? If shrinkage is not a possibility, doesn't that also end the warping shrinkage theory? No. I'm not talking about, you print a tower and then once it's not linked to the bed anymore, then it cannot shrink on anything. What I'm talking about is, that line on the bed. So does that mean you will have elephant foot for all your print because they shrink? So you cannot avoid elephant foot, basically. So the shrinkage, even if you put the shrinkage, how is that going to help? It is not moving. Things that are hot are usually larger, and when cool, it shrink. But I mean, this first layer here, I print 100 millimeter square, okay? My first layer. How does it become a 94 millimeter square? It cannot, right? Do we agree with that? Okay, so John, what you're saying is while it's printing, it's not shrinking. Then when is that gonna shrink? Shrinkage rate. I believe it helps when a part is designed for PLA and a mechanical fitment and you want to print in ABS. But again, you are not answering the question. Do we all agree that the first few layers cannot shrink? Because otherwise I really don't understand why you're printing a line on your bed that's here and then suddenly it moves. I mean, that's impossible, right? When it's fully cooled and off the bed. John, most of the print, they are already fully cooled even before finishing the print. The shrinkage is only in tenths of a millimeter, even though it's a small shrinkage, it cannot. If something is stuck somewhere, it cannot move. It's stuck. So it's either you have an elephant foot because it's going to shrink after, or it cannot move. That's impossible. It's talking about the whole model shrinking. ABS definitely shrink more when cool. And it's very, very minor. I'm not advocating either side, only trying to define what's the intent. Above the first layer. Okay, so basically the first layer is the one that doesn't shrink, and then the other layers are the one that shrink. And the first layer cannot shrink because it's stuck to the bed. So it's elephant foot, right? So you have a bigger elephant foot with ABS than you have in PLA. Is that from your guys' experience? The ABS has a bigger elephant foot than PLA? Agreed. The first layers are stuck to the end and do not shrink, but maybe they are trying to adjust for upper layers, which, as you said, could end up with elephant foot because it adjusted the whole part. There is another setting for elephant foot first layer compensation. What is that? First layer compensation? How does that help with the elephant foot? Zen Bender, where can I find that? There's another setting for elephant foot first layer compensation. First layer compensation, maybe in the printing setting, I assume. First layer. Is there a search function on this? No. Oh, search. So what did you say? Compensation. Modifying slice. Filament property, shrinkage, slicing. No. Maybe elephant foot. Maybe this. I like the red arrows. It's pretty nice. Okay, XY first layer compensation. Okay, so I guess you're talking about this, right? First layer. The first layer will be grown, shrunk in the XY plane by the configured value to compensate for the first layer squish, aka the elephant foot. No. Elephant foot for layer squish is one thing. Elephant foot for the fact that the first layer doesn't shrink and the other layers shrink is another thing. You cannot compensate the elephant foot from the fact that the other layers are shrinking by doing this. That's different. And that's what I was thinking. Elephant foot for people has nothing to do with what we just explained. Because people think that the part will shrink evenly, which doesn't make sense. The first layer cannot shrink. Elephant foot for people is basically you squish your first layer because to have a better bed adhesion, and the fact that you squish it, it will be a little bit bigger than the other. That's how people perceive elephant foot. That has nothing to do with the shrinkage. So that's why you have this. Shrinkage, as far as I have seen, it's mainly seen on holes or small features. Also looks like ABS and ASA shrinks when you let it cool under the TG. That's why if you cool your bed, the model just get loose of the bed pretty easily, or maybe I'm wrong. Yeah, well, for this one, it depends on which of the warping theory you believe in, but for me, it's correct. Advanced slicing. Yeah, okay, got it. Yeah, I got it. Actually, the search function is pretty nice on the Super Slicer. 94 millimeter, 99.4. That isn't for shrinkages, but for squish. Yeah, John Game. That's exactly this. Elephant foot for people is for squish. Like, so can I do an elephant foot with with PVT easily? No, maybe not. Maybe this. Oh, you know what? Like this. So if you print a cube, then you have two kind of elephant foot. Elephant foot number one, you squish the first layer, and the fact that you squish the first layer, then it will come out a little bit. Okay, elephant foot number two, the first layer is printed at 100 millimeter. Okay, so that's 100 millimeter from here to there, and then the other layers will will actually, you know what, it should be continuous in that case. So the other layer will but let me exaggerate a little bit, but the other layers are going to shrink. Okay, but the first layer cannot shrink because it's stuck to the bed, and then the other layer is going to shrink. So you will have some kind of thing like this. Okay, so the elephant foot on one case is very abrupt. Okay, something like this. But on the other case, the elephant foot is more something like this. If shrinkage is a thing, okay, it should be something like this. I'm exaggerating. Like most likely is something like this, and it's more curved than linear, I assume, but something like this. So we are talking about two different elephant foot, and I think people didn't even think about that elephant foot because they somehow think that when it shrink, then everything shrink. But how about the first layer? Print setting slices XY. Yeah, I got it, Zenbender. Thank you. In Prusa, default to 0.2 for squish, not for shrinkage. Right. I don't agree with compensating this way for shrinkage. If you did, you would have to find setting for both. I would just scale the model, the percentage of shrinkage. Yeah, Zenbender. But if you are not solving the elephant foot if you only use shrinkage. If you only use sorry, where is my here? If you only use shrinkage, then you are not solving the elephant foot problem. Because let's say you put here, I don't know, the shrinkage of my filament is I don't know, I don't know, 99%. Okay, so it's gonna scale up in order to have the right dimension at 99%. Okay, so it's not gonna solve your elephant foot, because if your shrinkage is 99%, then most likely it's gonna print a little bit more than 100, so that it's gonna shrink back to 100. But the first layer is not gonna shrink back. The rest is gonna shrink back. So you're not solving the elephant foot this way. Sorry, my delay is bad. So you already said things well after I tapped them. Yeah, no, I'm also very late in chat usually. Some models, like all Voron parts, are pre-scaled up to account for shrinkage. Yeah, okay. Randall Borg, thank you for joining. For me, if it was designed with shrinkage rate of PLA and I'm printing in ABS, it would be easiest to scale the model, blah, blah, blah. Okay. Okay, so basically this elephant foot, then we cannot solve it, right? A lot of designers don't even know that there is different shrinkage rate for different type of filaments. Yeah, I mean, even the shrinkage rate for me is useless in a way that it depends so much on your printing geometry, your printing setting. It depends on so many things that I think is useless to use this. The best way to do is fit testing. If you're printing something and then something else that needs to fit together, the only way is just to print it and then to try, and then you just modify accordingly. I mean, if you print fast, if you print at low temperature, if you print, depending on how you print, it's going to be totally different. So yeah, I really think this is useless. And even shrinkage, like, depending, what I prefer is XY expansion, I think it's called. Or I don't remember how it's called on Ultimaker, but it's gonna grow your different holes, or it's gonna shrink your holes depending on the result of your fitting test. I think that makes sense. But this shrinkage, no, it doesn't make sense. In injection molding, yes, I think it makes sense. In 3D printing, no, I don't think it makes a lot of sense. Isn't it the reason to print pull-ups from the corner of a print is to shrinkage pulling the print from the bed as it cools? Sorry, OneRise, do you understand? These tests get you further than stock settings. Then you adjust per model if needed. Yeah, but then it's useless, right? You would directly change your model. Yeah, horizontal expansion. Was it called horizontal expansion? Yeah, maybe. Proper design will take shrinkage into account at design time in CAD. Then it would only come into account when using a filament medium to print with. Is there some test that has been done on this? Like, is there some papers or stuff like this? Let me check. Shrinkage rate 3D printing. Research. Experimental investigation of shrinkage of 3D printing parts. Okay, 3D printing is a very popular engineering blah, blah, blah. Objective. Numerous engineering programs across the US are using 3D printing technology for their students. Blah, blah. Dimensional accuracy is very important in most of these projects. The shrinkage of plastic leads to dimensional inaccuracy for 3D printed part. The objective of this project is to find out how shrinkage is related to the size of the part that is going to be printed, as well how other printing options like infill percentage affect shrinkage. Purpose, blah, blah. So they have a fixture and they need to fit together. Okay. Methodology. A series of hollow cylinder specimens were printed using ABS in a FlashForge Dreamer 3D printer. It is noted that the printer has a resolution of 0.004 what? Resolution of something, and it uses filaments of 1.75 millimeter of diameter. The table below shows the configuration of specimen. Blah, blah, blah. Okay, so they print different ring. The inner diameter is this, the outer diameter is this, and the infill is this. Okay, and I guess the infill pattern would be important as well. The specimen were and the number of walls and the top and bottom layer, because it's gonna prevent the anyway, a lot more needs to be taken in account, I guess, but I guess they are the same for all of them. The specimens were also printed with different infill percentage while keeping the size constant. Okay. Result and discussion. The plot below shows the percentage of shrinkage decreases as the internal diameter of the part increases. Okay. So for example, here, you have a very simple part, right? But the shrinkage rate is apparently completely different depending on the size. And I mean, it's not a big difference in sizes, right? And you have to, can you imagine here, you have to input a completely different shrinkage rate. So I don't know, it would have been, I don't know. I don't know if it's very useful. If it changes for every model, then I don't know. I can see some ways where it can be useful. But anyway, so that was the result. And then again, I don't know where that source come from, and I haven't done much research, so we'll just believe that the results are correct. Shrinkage versus outer diameter. The above plot showed that the shrinkage of external diameter is very small as compared to the internal one. That's very interesting. That's very interesting that the outer diameter doesn't change much, but the inner diameter change. Also, the external shrinkage change is very insignificant as the size increases. You see, that's how is that possible? This is very interesting. The inner diameter shrinks, but the outer diameter does not shrink. What would be the explanation here? You know what would be my explanation? My explanation would be that the outer diameter cannot shrink as much because you have solid stuff on the inside, so it cannot shrink. Okay, it's prevented by what is inside, but the inner diameter can shrink because inside is just air, so there is nothing to prevent it to shrink. So that's my hypothesis. What do you guys think? But my hypothesis is this: the outer diameter cannot shrink because there is something holding it, but the inner diameter can shrink because there's nothing holding it. That's what we were talking about when we talked about, do you remember the Benchy Hurl line? It could be, our hypothesis, or at least the hypothesis I put on stream was exactly this, was exactly the result they had. Okay, the next graph is shrinkage. I mean, I like this because it's a very simple test, but you can learn a lot. Next one, shrinkage percentage vs infill percentage. The percentage shrinkage decreases slightly with increasing infill percentage for the same size inner diameter. But for the outer diameter, the infill percentage does not have much impact. Okay, my hypothesis here is if you have, so for the outer diameter, whatever the infill, it looks like the shrinkage percentage doesn't change much. And again, I think it has to do with the walls, the top layer, the bottom layers. So these are the main things that are holding on. And then the infill might change a little bit, but not that much. But maybe for the inside, then yeah, I don't know. Maybe the higher the infill and the more it will hold the inside ring or something like this. So anyway, the conclusion: in the current research, an experimental investigation was performed to see how shrinkage varies with different parameters for a 3D printer with ABS plastic filament. The finding of the research will be very useful while working on the 3D printing project, since one can adjust the dimension in the design phase by predicting the shrinkage to obtain the desired final dimension. Okay, so yeah, a quick research here, but I think a very interesting one. Hi, Stephen, Francis. Thank you guys for joining today. Would a BRIM prevent or limit this? I think the BRIM is not going to change anything because the BRIM will only be connected to the first layer, and we already said that the first layer cannot shrink anyway because it's stuck to the first layer. So I don't think BRIM's gonna change anything. I would imagine a BRIM might only help the first layer, but not anything above that. Yeah, but even the first, it's not going to help the first layer in a way that the first layer is stuck to the bed, so it cannot move anyway. What you could do is a BRIM, a multiple layer BRIM. Then yes, but then good luck to remove it. I think that makes the most sense. The further out you go, the more constrained you are by the interior geometry. Could also be a large stress on the constrained shrinkage. Yeah, I agree with that. You may have a lot of stress on the outer link because it didn't release that stress. Yeah, that's a good point. But let's cross. Let's still find some other study just to make sure that they have similar. Okay, so they don't have any here. Research on shrinkage model with holes in PLA. Okay, so how does PLA look like? Blah, blah, blah. 3D printers making solid object. Okay. Huh, interesting how they call driving roller, guide sleeve, nozzle, model, workbench. That's interesting vocabulary. Factors affecting the shrinkage roll, blah, blah. Let's directly have a look at the graph. Do they have any graph here? Okay, so they are using the same way. They are printing rings. Okay, blah blah. Conclusion. Okay, so they don't have graphs, so we'll have to look at the table. Level 1, hotbed, layer thickness, blah blah. Measured value, size error. According to the data in table 2, the mean and the difference of the dimensional error and the different factors level are calculated by the range, blah, blah, blah. Measure reduce the shrinkage of the shrinkage of the model with foil is related to the extrusion heat temperature, head temperature, hotbed, layer thickness, and printing speed. Oh, okay. That's interesting. So this research is actually, it's actually checking the factors, the printing settings, like extrusion speed, bed temperature, nozzle temperature. And then according to this, it's defining the shrinkage. That's very, you know what? Let me just record that. That's very good for warping. Let me just put this here. Oh, actually, that's my computer stuff. Maybe I should link maybe I should link this. Oh, it's directly downloading. So maybe save the link, copying the link address. There you go. Yeah, there you go. So that's interesting. I don't know if we can. Let's just check the conclusion directly, but let's. I think we should take a look at this in more details, because warping is also about how the stress change depending on the printing setting. So the factors of affecting the shrinkage hole are extruded head temperature, hotbed temperature, layer thickness, and printing speed when printing the model with holes. In this paper, the orthogonal test of 4 factors, 4 levels is designed, and the optimal combination of process parameters reduces shrinkage error of models we have is obtained with, which is A3, B1, C1, D2. That extruded head temperature is 210. Hotbed temperature 45 degree, layer thickness 0.1, printing speed 45 millimeters per second. Finally, the concrete measure to reduce shrinkage of model with holes is put forward, which is practical significance to solve the problem of model. Okay, so the best one was this one. So A3, let's check. Okay, so that means the hotter you print, the better. And then so A3B1. Okay, so the lowest temperature, the lowest printing speed, and the lowest layer thickness. So I'm not surprised for the extrusion temperature, because you know that I'm a big believer in the elastic shrinkage theory, right? So if you're printing at a high temperature and at a low speed, then I don't really believe in the shrinkage, the thermal shrinkage. So if you print at a high temperature, then you are going to actually release the stress. So that means it will shrink less. So I'm not surprised that a high extrusion temperature and a low speed is what will work to reduce shrinkage. And then I'm a little bit surprised that the 45 bed, actually for me there's no much difference whether it's 45, 50, or 6, maybe 60 because it's kind of at TG, but 45 and 50 for me there's no much difference. We can look at the data, but I'm pretty sure I don't know how to read that properly. And then layer thickness 0.1. Let me think. Yeah, I'm also not surprised in a way that 0.1 means you extrude, the flow is less, so it means also a higher extrusion temperature. So everything is toward higher extrusion temperature, which is in the elastic shrinkage theory, which is the way to solve that. In the thermal shrinkage theory, I still have some doubt on how people put that, but the higher the temperature, theoretically the worse, because you have a bigger difference. It shrink more in the way that from the 210 to the room temperature. So that's very, very interesting for warping theory. Actually, it's a paper that we check for for something else, but it's interesting. I highly suggest you guys to read this more accurately than I did now. I will read it more accurately, but I don't want to make the stream boring and then just look at me reading this. But let's just all read that when we have more time. But very interesting, very, very interesting. Sorry, I haven't been reading this chat since. So hi, Jerry. Brittany, thank you guys for being awesome. Okay, so basically we were talking. I forgot what we were talking about. Yeah, we were talking about the shrinkage, and then so my conclusion is that don't think that each filament has a shrinkage rate. It's really each model, filament, everything has a shrinkage rate. So whatever you're printing, then you have to try, and then try if it fits or if it has the dimension you want. And if it doesn't, then you have to modify accordingly. But depending on what you print, how you print, with what you printed, where you print it, then it will be different. So just something to keep in mind, instead of just putting one shrinkage rate for one filament, and then think that all your model is going to be calibrated to the right thing. When are we going to discuss hot end again? In Saturday. Saturday we're gonna continue our hot end discussion. Okay, so that was that was for the shrinkage rate. Where are we again? Yeah, here.
For Super Slicer, the slicer I currently use and recommend, this can be found in the filament page. Once you've made the necessary adjustments, the best way to check that everything went to plan is to repeat the print with the same material and take new measurements. Hopefully, you should find that the error is dramatically reduced compared.
I mean, even if you take the measurement, let's check how he took the measurement. Yeah, you see how it took the measurement? Then how the first layer will definitely affect this measurement. I mean, he's taking in a way that it includes the first layer. And like we said, the first layer cannot move. So how does that gonna show us the shrinkage? You get what I mean? Like how he measure it? If let's say, you know, your printer is supposed to do what you're asking for, right? If you're telling him, for example, here, 49.7, I assume it's supposed to be 50 millimeter, right? So let's go back here. So he's printing a line here. Okay, so this line is this line here, and then let me move that here. So this line here, and then the other line is supposed to be here, and it's supposed to be at 50 millimeter away. Okay. Then if it's not 50 millimeter away, then the only thing that can change is the thickness of that shell, that perimeter. But there's nothing to do with shrinkage. It's only that the thickness of this that may be thinner. So let's say, you know, I don't know how the slicer do, but I assume the slicer is going from the outside of that thickness. So if your model is 50 millimeter, then I assume they take the thickness of that line on the inside, right? So that means it should be 50 millimeter. If it's not 50 millimeter, like 49, in that case it was 49.7, then most likely I would take 0.3 and then divide by 2 so what, 0.15, and then I would assume that my thickness here is 0.15 less. But that means if it's 0.15 less on one side, it has to be less on the other side as well. So that's 0.3 millimeter, which is impossible. So there is a problem here. You get what I mean? Let me put this. So let's say we zoom in a little bit. So I'm printing at 0.4, right? This is supposed to be 0.4, but when I'm measuring, then you know, it's only 49.7. So on one side here, it's 0.15 shorter. Okay, and it's also 0.15 shorter here. But if it's 0.15 shorter here on the outside, then it shrink evenly, right? Because it's printing in the middle. So that means, sorry, I hope you guys are following me, because I'm going a little bit far here, but which means if it's 0.15, then it's 0.15 on both sides. 0.15 here, 0.15 here. Okay, it cannot only shrink on one side. So that means your printer has extruded at 0.1, which is impossible. You can, I mean, otherwise you have another problem than just calibration. So how can he has 49.7? The only reason I can see that is either when he measured, then the first layer He actually has a how do you call that, indent? Indent. Is that the right name? Start line position further from deepness. Notches. Yeah, a notch. Like he's pressing so hard with his caliper, then that is actually deforming the first layer. So he's deforming the first layer, which means he's measuring the the actual model, but not the first layer, because he basically notched the first layer, because it's only one layer, so it's not very solid, right? That's reason number one, which I guess it is. But if it's this reason, then there's no way. That's the point of this test. It sets the same scale factor for all filaments. So if you print any model with any material, they should be fairly close. The same scale factor for all filaments. That's the point of this test. It sets the same scale factor for all filaments. So if you print any model with any material, they should be fairly close. Let me think. I mean, we just reviewed a research paper that says that, I mean, there is literally a 2% difference in shrinkage rate depending on whether you print it at 30 millimeter or 40 millimeter. So I still think it's useless in a way that it changed too much. I mean, if that research paper, which I don't have anymore, but let me check. If that research paper, oh, not this one. Yeah, this one. If this is correct, or this one, I mean, you have a 1% difference between printing at 40 millimeter or at 20 millimeter. So you double the size and you reduce by 1% the shrinkage. So can you imagine going from this test to an actual print? Then it's completely different. The shrinkage rate will be completely different. So how useful is that? That's not even how you use caliper. Oh, you mean the way he's using it like this? I don't know. I mean, I'm not an expert in using caliper, but I don't see anything wrong on how he uses his caliper, or at least I'm using it the same way. I don't know how it should be used. Your measurement is where the tip is, which should be halfway down the side for this test. Yeah, if he is doing, your measurement is where the tip is. Yeah, I mean, if he's doing like you said, then he's not taking into account the first layer, or like the elephant foot. Then yeah, I understand. But I mean, it's his video, right? It's his test. So I believe he knows how to use it. Chamfer, the first 1 to 2 millimeter elephant foot won't matter. All Voron parts are pre-chamfer on the bottom, so new user would still get accurate part. Yeah, Kenneth saying chamfering your part is a good idea for elephant foot, or actually for a lot of different things. The only thing it doesn't help is warping. I think it's making it worse. Measure the outside distance and inside distance, so the average cancels out. Nathan, maybe I miss what you mean. Chamfer 2 millimeter will avoid all elephant foot and epensons. I don't know what is epenson, but yes, I agree that the chamfer helps with elephant foot. Make sure to watch his updated video on these two. I watched it, but there's no information there. We can finish that one and watch the other one, but there's no information. Nothing useful from what I remember, but I watched it quickly. Maybe there is in between what I watched. Prusa Slicer automatically has a 0.2 millimeter elephant foot compensation for the MK3. Yeah. But I think that's John. I think that's for the regular elephant foot compensation. I don't think it's for the shrinkage compensation. Indent equal chamfer. Oh, okay. You print this test with your normal settings, so other models have the same or similar speed. This is going to get your printer 100% calibrated, just closer to the right side from the 40, 50 flowers I've printed. This is going to get your printer 100% calibrated, just closer to the right side. Well, Zombie, think about this. Let's say this guy here make a Califlower to calibrate his printer, okay? With he used ABS, Flashford, Dremel, he used everything, and then he calibrated this printer. How useful is that going to be in order to have this ring to be the right dimension? It would be useless, right? Because in any case, the flower is not going to help with his with printing the ring. So in that perspective, I think is useless in a way that whatever the part you're going to print is going to be different. I mean, look at this. Like maybe let's say he print his cauliflower, and then he say, okay, let's say he's not taking the same measurement as he is doing, but let's say he's taking the right measurement of the top, blah blah blah, and then okay, the shrinkage range of that model, not of the filament, of that model with the filament is, I don't know, 0.5%. Okay, great. Then he put 0.5% in his slicer. And then he said, okay, my printer is calibrated. Now I'm printing the rings. And then the rings are completely out of specs. Yes, because the shrinkage rate was for the cauliflower, not for the rings. You get what I mean? Like the shrinkage rates for the rings are completely different, depending on what inner diameter he's printing. So he needs this ring, and then is out of spec, and then he print another ring, then he's out of specs. Then whatever ring he print is out of spec. There might be one ring that is in spec because the shrinkage rate will, by random chance, be the same as the cauliflower. So that's my meaning on why I think it's useless to talk about shrinkage rate here. He's definitely not using that caliper right in that picture. Okay. So how do you use the caliper then? Let's do a small parenthesis here. How to use a caliper? I mean, is there a right way and a wrong way to use it? I mean, for me, he's doing this, right? I mean, he's correct. Yeah, you see, he's doing this. I mean, for me, they're all using it in the same way. I don't know. Like I said, I'm not an expert at using caliper, but maybe what you're saying is he's not measuring the right dimension. Maybe he needs to stop halfway or something like this. Maybe in that way you mean. Can I recommend we watch the whole video together, then go back and comment on in detail? A lot of stuff you ask get answered 5 seconds later. Okay, yeah, we can finish the video.
And take 3 readings. Type each reading into the column.
But let me finish the comment first. You need to use the tip of the calipers, I think, instead. Okay. Expansion, yeah. You can literally see it crooked. They have cut out on the tip for a reason. Okay. So you're just calibrating the shrinkage of the cauliflower, not other model you might print. Yeah, that's what I think, John. What if he printed the cauliflower on a raft? Would that remove the variable of elephant foot? Yeah, that's a good point. Maybe yes. Maybe that's a good idea. Come out on PLA. That's a very good idea. I mostly use it so I can print different parts of the same model without needing to test. Horizontal expansion then would be the same for all filament. I mostly use it so I can print different parts of the same model without needing to test. Horizontal expansion then would be the same for all filament. But I mean, if if you use the calibration flower just to print one model, then you better just calibrate your printer for that model. Then, or maybe I didn't understand your question. The tip of the caliper is slightly larger and is the only part that makes contact. Oh, okay. Oh, okay, got it. So you cannot use that the part there. You can only use, because I remember on the caliper the tip is like sharper. Okay. Yeah, that's good to know. Can I say that I know how to use a caliper now? He has the caliper tipped up and crooked in will change the measurement. Okay, got it. He also mentioned in this video that same printers wouldn't benefit from this, apparently, like the Prusa. Okay, so yeah, let's listen to Zombie suggestion. Let's finish the video first.
And take 3 readings. Type each reading into the corresponding box on the calculator, and it will then calculate the average for you. Repeat this process. Trust me, is the percentage error on X and Y, and also the amount of skew and the correction factor that you need to make. Below this part of the calculator, there are dynamic text fields, which can be copied into either your Marlin firmware or Clipper config file to implement the skew correction factors that are specific to what you've just printed. If the measurements on X and Y are more than 1 millimeter away from the target, then your steps per millimeter is probably incorrect. But if your dimensions are close, then the XY shrinkage in your slicer is a great place to implement varied expansion rates for different filaments. For Super Slicer, the slicer I currently use and recommend, this can be found in the filament page. Once you've made the necessary adjustments, the best way to check that everything went to plan is to repeat the print with the same material and take new measurements. Hopefully, you should find that the error is dramatically reduced compared to your first print. Finally, congratulate yourself on a job well done and get going with your next 3D printing project. The link for the STL file with the written guide and calculator is in the video description. Thank you very much for watching. Good luck with your calibration, and I'll see you in the next one. How accurate?
Yeah, so we finished the video. Yeah, let's have a look at his updated video. So my main point, I want to summarize again. My main point is the calibration he's talking about seems to be very model dependent, especially, looking at the research we just saw. Again, I don't know how accurate is this research, whether it's correct or not. We would need to do more research, but I don't know. It's yeah. Okay, so that's the the best calibration method just got better. And once again, this isn't a test to get whole size right. You need to adjust per model. Yeah, but that's the point, Zombie. If you need to adjust per model, then what's the point of having this calibration stuff? Because is it this calibration to help with shrinkage rate? Because if that's the case, then it's useless in a way that it only gives you the shrinkage rate of the calibration flower. Yeah, it's a way of checking XY step per millimeter overall. Oh, John, you're going into an area where PRINTBUSTER has defined that the XY step do not need to be calibrated, but we can put that discussion back on the table. He finished all his sentence on and up, not like teaching tech. I just checked, and both my calipers have the same measurement on the entire length of the measurement tip. Yeah, I thought so too. You can maybe get it closer than it was before. I don't know. Maybe the bed is hot and it shrinks after removal. The bed is hot and it shrinks after removal. Yeah, then if you don't use a heated bed, then that solves the problem, right? The tip is also narrow too. All calipers are a bit different. Yeah.
Hello everyone, and welcome back to the channel. Today we're taking another look at the calibration flower, as I'm going to run you through some of the new updates we've got in the calibration software, as well as minor changes to the flower, and then we'll run.
Sorry, he was saying that there may be an issue with your XY step. No. I think he was talking about the E step. In the other video you were saying, right? I think he was talking about the E step, not the XY step. If it's 1% off, not necessarily that you need to calibrate XY step. I think he was talking about the... yeah, I don't have the video open, but I think he was talking about...
run through some tips and tricks on how to use the calibration software, like I say, software calculator that I've made. And then I'll show you a cool little use for these. First thing, I just want to recap, if you below the flat rules that we've had with...
yeah, so we just watched the video.
So the first thing, and maybe the most important, be like Califlower, bit like cauliflower, the Califlower. The changes I've made there, which might be useful for you. If you've...
so I just skip because the first thing was just the name.
Now it probably will. So the first thing is we've added a bunch of, I've added a bunch of kind of interpretation of results, what they mean and how to implement. There's a bit of an extra guide just within the calculator to help you get the most out of it. I'm also going to run through some extra stuff at the end of the video, just in case you want some more.
Hey, make a meal right.
The next thing I've added is down at the bottom of the calculator. I've added a zone for steps per millimeter or rotation distance.
Not exactly. The line trace is also put down at a higher temperature, but can move after it is touching the bed. Even a cold bed will have the filament shrink after the print is finished. Jaren, the line trace is also put down at a higher temperature, but can move after it is touching the... I don't think so. I don't think the filament can move after it sticks to the bed. Like you cannot print the line of filament and then the filament is, you know, changing position. I don't think that's possible.
So before it was just calculating the error, which was what we find.
Of course you're designing
but now it
right.
actually does that calibration of the steps per millimeter.
Hi, Robert,
so you've got those values that you can implement. The next thing I've added in terms of fixing skew is commands specifically for RepRap firmware. So before I had some, so you're good to go.
Yeah, so there's some common stuff.
Is the command which you can copy out the enable use. So as to again, if you've already used this problem where we've got a slightly sharp corner with it, we're going to be getting it from now to the calculator itself.
Yeah, and then the calculator moved from Excel to Open Office.
The stuff that I need to make on my original video is that I said you could do iteration specifically with skew, and that doesn't really work with this calculator in its current state. It's technically possible, knowing the pre-skew and after skew, and you'd be able to work it out. But for this, it's just a single step, your before and your after. I have found though that you actually don't really need to do any iteration. A single run of this calculation should be enough to get you exactly as far as you need to go, even if you're quite a long way out to begin with. As long as your measurements are reasonably accurate, you should be fine. One maybe negative thing is in terms of the downloadable kind of set of files that I have online, I'm going to be changing it to...
Yes, but the line width of the trace will change. The line width will change, maybe slightly, yeah. Yeah, there is a possibility that the line width slightly change. Yeah.
Just have the calibration, the Califlower in the files which I'm charging for. Now you'll just be getting this and the calculator. Before I had my bridging and overhang test, I've not really them and I think the stuff they weren't really being used very optimally anyway. So that's kind of it for the updates and stuff. It does continuously improve. This has not just been a single Bosch update. It's been kind of updating every few weeks or so, pretty much since it was created. Just kind of as I get feedback from users and their specific use cases.
Viking.
So this is where we're at now. I thought it'd be good timing to do an update on all the things that we do is run through how you could use this calculator to do what you just read it slightly differently or format to change the scale. But if you have a particularly large printer and you really want to do it at a larger scale, you can. Every consumer panic have input. You can see the doesn't mean.
Yeah, like I said, Zombie, there's I watched it already. There's really no valuable information inside. not valuable information in terms of understanding how his calibration workflow works. So, for example, here, what I want to know, yeah, there you go. So let's have a look. Blah, blah, blah. So you're measuring a bunch of stuff. He's making an average, an error, and then he's changing that. So what the result mean? If X and Y errors are both negative, your print is undersized by the percentage of blah, 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 okay? If X and Y errors are positive, is oversized. If X and Y errors are very different from each other, check your step per millimeter or belt tension. Oh, okay, so maybe you were right, John. Maybe it is related to XY. If you have core XY, X and Y are locked to each other, so use the average of the two errors, blah, blah, blah. So you see, that's my problem. My problem is he's not explaining why. For example, if X and Y errors are both negative, your print is undersized. Why the print is undersized? Is that because your flow is not high enough? Is that because your printer is not calibrated, or what's wrong? And then, so to know what's wrong, we can have a look at what is he changing. And when we look at this skew XY, skew blah blah blah, because on the way Excel work, you may find get switched to regional skew correction, send command. Okay, so here is the skew correction, but I want to see what is he doing for the X and Y, or is that all about the skew? I think on his first video he was calibration tower, calibration flower. You know what I mean? Like, why? Okay, so my print is undersized or is oversized. Then why? What's the reason? So it's oversized by a certain percentage, and then he's going to change something in my firmware or slicer. I don't know, firmware most likely. He's going to change something, and then he's going to print fine. So what is he changing? Maybe I missed that in the video. Blah, blah, blah. Okay, here.
The correction factor that you need to make. Below this part of the calculator, there are dynamic text fields, which can be copied into either.
Okay, so skew profile save equal my skew profile. Set skew XY 99.69. Okay, so that's this 98.88. 98.69.59. Where does that come from? Okay, so I guess there is some. Okay, so there is some kind of calculation. So he's only changing the skew. So the only thing you are calibrating is the skew. Is that correct? Zombie, is that correct? So the only thing you change after you do the calibration flower is the skew in your firmware. Yep, just wanted to make sure it was seen. This test is done after flow calibration. So if it's off, it will show up here. Oh, so it's not even a flow calibration. So what, maybe I should have asked this at the beginning, but what does it calibrate? I mean, it's the best calibration method, right? But what does it calibrate? Maybe I should have started there. What does it calibrate? You see, calibration flow. Oh, but I guess he's talking about the flow, like the process. Yeah, sorry. Quite simply, this 3D printer calibration method greatly improved my print. This calibration flow is simple and robust method of calibrating the X and Y axis of your printer to get more dimensionally accurate print. Okay, so it's calibrating the XY axis of your printer. I hardly need to show you how to calibrate your printer. You simply print, measure, update your setting. Most instances only require a single print to get amazing result. In my opinion, the best 3D printer calibration method available at the moment. Okay, so it's calibrating the X and Y axis. So now the question is, what is he changing on the X and Y axis? From what I've seen, only the skew. Only the skew is changed, nothing else. And then he's saying if it's too off, then you have to calibrate the step per millimeter of your X and Y. So it's not even helping for calibrating this. I guess you have to use a different calibration. So the Califlower is to calibrate the skew. Is that a great? Is that a good summary? Yeah, he's only having you change skew, the overall dimensional accuracy of your X, Y, E, but that doesn't affect the E, right? The skew. It only affects X and Y. It will change depending on the object, but I'm sure this gets you closer. But then, no. What I said it will depend on the object is the shrinkage. But the skew is the same for everything. The skew is about the printer, right? So if you calibrate the skew, then great. This model calibrate the skew, and then that's it. It's going to be calibrated for everything. It's not model dependent. This calibrate the shrinkage, like what you would do with a 20mm cube. Well, that's not really what he's saying, right? It's not about calibrating the shrinkage. It's about calibrating your X and Y axis. And if we go into the detail, it's about calibrating the skew, which is, how orthogonal, how perpendicular your X and Y is. Yes, so if you print a circle gear, it comes out round and not egg-shaped in this theory. Yes, Zenbender, that's a good way to put it. I actually had no, Zenbender. So let me put it this way. If your skew is not calibrated, you will get an egg shape. But if you get an egg shape when you print around, it doesn't mean it's about the skew. It could also be an XY issue, like the Y is going somehow is doing a percentage higher than the Y. The X is doing a percentage higher than the Y. So yes, a bad skew will do an X shape, but no, an X shape doesn't always mean it's because of your skew, just to be more precise. I don't know why he doesn't go over the flow calibration part of it. The skew is a bonus feature. Oh, really? It seems to be the only features, right? There's nothing else you change. I mean, what else are you going to change? Because on his calculator, he's only calculated these. You see result. You have the XY and the skew, and then and then it's dynamically giving you the comment that you need to put in your firmware, and then that's it. It's done. The point of the flower is to make the final part be the same size as what you tell it. Yeah, then I think it's a very bad calibration model. I don't think, and in any case, I don't think there is any calibration model that's going to help you with that. It's impossible to make one model that is going to calibrate all your model. There is no model that can help you to have all your model the size that you are asking them to be. No, but it will show up on the calibration if your each step are off, is all I mean. In his second video, he briefly explained that the calculator figures out the center of the walls so it can tell what the inner outer error is. Okay.
So one thing that maybe gets missed with angles is they don't change with scale. So
where in that video? Why isn't my printer perfect? Conditional format, tip and tricks. Skew doesn't scale. L printer compatibility. L iteration 7. Yeah, I mean, if flow is something important, then it should have. Was it just like a quick saying? Somewhat egg-shaped 82 gears was an issue, but now most use metal machine gears. Yeah. Does this version not show the inner outer flow percentage? Well, again, I don't have access to the paid version, but definitely. Oh, you have. Is that what you're talking about? Inner outer error correction. Inner and outer errors are average that includes X and Y dimension that may be useful to diagnose over and under extrusion. If inner is negative, and outer is positive, this could indicate over extrusion. If inner is positive and outer is negative, this could indicate under extrusion. Yeah, but that doesn't help because you say that this is after you calibrate your flow. Isn't what you said? Let me check. Blah, blah. Or maybe, yeah. Zombie, you said this test is done after flow calibration. So it's basically just a check, right? It's not really calibrating your flow. It's just checking that your flow calibration was well done, which then it's not really a calibration. It can verify if your flow setting is good. Yeah, it can verify. Hey, Matt German. So, yeah, for me, it's very good for the skew. And that's it. I don't see any other, because, okay, I mean, you can check if your flow is good, but there is, I mean, do you need such a design just to check if your flow is good or not? I mean, for me, the CNC kitchen is much better because this one, I mean, how do you know? You have to print that in many different speed, in many different temperature to know if the flow is good. No, I don't think it's very good. I mean, are you really going to use the calibration flower to check your flow after you do a CNC kitchen test? I don't think so. I use it to check, calibrate my printer skew, verify the flow, and just the shrinkage rate per filament. Calibrate the printer skew, I agree. Verify the flow. I would say CNC kitchen test is well enough for that. You don't have to have this, I think. And adjust the shrinkage percentage per filament. Again, I disagree that there is one shrinkage rate per filament. We just saw it via one of the research. It's so different per model that there's no point of checking one model. For me is useless. CNC kitchen, it's as useful as just Google the shrinkage rate of a material and just putting in your slicer. CNC kitchen is more for testing maximum extrusion. It's not for testing maximum extrusion. You can test the maximum extrusion, but it's about knowing if you are extruding what you're asking for. Because you can put a certain volume extrusion at a certain temperature, and then you check whether you are extruding what you're asking for. If you are under extruding, then you can increase your flow. If you are over extruding, then you can decrease your flow, and then you have exactly what you ask for. If you increase the flow and it's still under extruding, then it means you have reached the limitation of your printer. This test must work well because everyone prints model around this size. But it's more than the size. It's your printing temperature. I mean, you see the second study, right? The second study showed that depending on the printing temperature, the printing speed, the printing temperature, printing speed, layer thickness, and the bed temperature, the shrinkage rate will change. So there is literally no point of doing a shrinkage rate test. Really no point. If shrinkage rate is very important for accurate model, then you have to do it with that model because so many factors influence. This study showed that these factors influence, and then this study showed that this factor influence. So, I mean, at the end of the day, what's the point to make one model to get the shrinkage rate of that model. That's what I'm saying. So you are saying skew, agreed. Flow, I think CNC Kitchen do the job already very well. Adjust the shrinkage rate, percent per filament, I think is useless. This test must work well because yeah. So that's so what calibration test would use you for shrinkage calibration? Then you shouldn't have to print the same model twice for everything. Well, there is a difference between what you shouldn't do and what what you have to do, right? Like, I mean, there is no calibration for shrink, like for your model doesn't exist. Like, you cannot calibrate the shrinkage rate of another model with another model. That you can get close. Like, if let's say you want to print a horizontal hole like they did here, okay? Then instead of printing the whole part, where somewhere in that part you will have a hole, then maybe you can estimate that this hole would behave the same way as just printing a ring, and then you use the same temperature that you are going to print the final model. You use the same everything, and then you figure out the shrinkage rate, and then you try. So you try to go as close as your model. It's like something easy to print that you think, you make the hypothesis is going to behave the same as your final model. I mean, it's like, I mean, all the designer, they do the same. You always see their big design, and then they cut off a part, and then they print it, they check how they behave, and then they put it back in their large model. I think for me, that's the best way to go if you really need something extremely accurate. If you don't need something very accurate, like it can be like more or less, I don't know, 1% or 0.5%, then you don't care. I mean, shrinkage rate is not going to be huge anyway. Once again, this test isn't for the whole expansion, just to make all print the same relative size. So I can print two functional parts in different material, and they will be the same size. But whole expansion is shrinkage also. I mean, you can put everything in the same umbrella. I don't know why you make the difference between whole expansion and shrinkage in general. I mean, the whole is changing side also because of shrinkage. It's, there's no difference. I don't understand why you make the difference. So I can print two functional parts in different materials that will be the same size. No, if it's different material, then you will end up with I don't understand, Zombie. Maybe we can jump on Discord after that. If my screw holes is a little tight, whether it be from slight over extrusion or due to shrinkage, to fix for me is the same. I pull out a drill. Yeah, I mean, that's another way to solve the problem, right? Holes are designed for a specific scale for all FDM model. For a specific scale for all FDM model. Sounds like we need to do more testing around this for sure. Yeah. It's always more testing will always help us to have a better understanding. I really like that we end up on this study and this study. And I just Googled that very quickly. I'm pretty sure if we continue Googling that, we'll have more study. And then we can try to have our own PRINTBUSTERS experience and then figure out. But so far, from my personal understanding, this calibration flower is only useful for skew. It's not really useful for the rest, or at least there's a better way to do the rest. I don't think it's the best calibration method for shrinkage or the best calibration method for flow calibration. I think there's much better than this one, but it might be the best calibration method for the skew calibration, which seems to be the only thing it's doing. Because you see, fixed skew, I mean, even if you go here, Marlin Fermi adjustment skew correction, and then Clipper G-code skew correction. So basically, the only thing you do here is to correct the skew. And I think it is the best calibration because it's the only one I know that can correct the skew. Okay, and I guess everything came from that. I guess, you know, because even if his first video, the largest thing he's talking about in his first video, you see the largest segment is don't ignore skew. So I'm pretty sure this whole thing started with making something bigger and taking into account the skew. I think that's kind of, I mean, we can try to invite him. I mean, I don't know him, but we could try to invite him on stream to ask the question directly to him. But again, I think first, you know, I, you know, do you want some stories? I asked 2 people if they would like to come present their product on PRINTBUSTERS, and I feel like people are a little bit afraid to present their product on PRINTBUSTERS just because the way we are approaching things. So I found it interesting. That was just a try. I definitely have some people that say yes, but I had some people that were like, you know, I don't know if it's not comfortable presenting on PRINTBUSTERS. I don't know if it's our question that are a little bit strange for them, or if I didn't reach the right person. But I can assure you that it's not easy to get someone to present their project or product on PRINTBUSTERS just because our history of our stream. So Michael, what are all of these messages? What are you doing, Michael? Yeah, no spamming. You're just too scary. I think our community is I don't know, if you really trust your product, you understand your product, and then, you know, there's no particular issue with your product, or if you know the issue, you know the pros and cons, etc. It you know, it doesn't matter whatever question, then you just take it easy and answer it. If you don't know, you don't know. If you know, you know. If you know, it's I don't know. Anyway, what was about? So yeah, so I can ask him if he would be interested in joining. I can ask him if you know, he can watch the stream that we are having now, and then I don't know, take some note on the kind of question we have, and maybe we can invite him on stream, and then he can explain us a little bit more about how things works. Because, you know, I mean, he's making a YouTube video, and it's very difficult to communicate all the information you really want to communicate in a video, right? But maybe on the stream, then it will be easier for him to explain everything properly. That there might be a lot of stuff that we are completely missing out on the Califlower. So and that's the goal of PRINTBUSTERS. We want to dive in, really understand the thing that we're missing out, but it's not perfect. We will always miss some information and stuff. So yeah. He has a Discord. Does he? I have no ideas. Let me check. He has a Twitter. Oh yeah, he does. He does have a Discord. Let me join his Discord. Yeah, nice. He does have a Discord. General calibration. Oh, he has he has the PRINTBUSTER topic straight on there. And I think I just saw a ring. Yeah, I just saw a ring. So I guess there is some discussion around there. I must have some setting enabled that affects only circle or something. I'm not sure what caused it, to be honest. Okay. Yeah, interesting. Yeah, there is a Discord. And it seems to be pretty active because the messages are from yesterday. There's a VZBot inside. There is some event, Radrick, Voron, disgustingly tidy. Okay, interesting. Maybe we can reach out to him here. Oh, looks like they are not using the right filament, but it's okay. We can do some giveaway to slowly, oh, great, hot end, extreme flow test, more bigger, more better, larger nozzle, faster printing. Great. I need help selecting a thumbnail, please. Oh, great, great. Oh, did he just made a video on nozzle? Extreme flow test. Awesome. I feel like there is a lot of synergy between this Discord and our PRINTBUSTERS. Because, I mean, think about the guy. The guy literally took the main calibration that everyone used and crushed it and designed a better one. So definitely someone that needs to be on our PRINTBUSTER community. Stop printing calibration cube. Literally what we did for warping, for example. Stop thinking warping is one thing. It could be some other stuff. So yeah, we should definitely invite this guy. By the way, I don't know what's the name of the guy, but Adam. We should invite Adam in our PRINTBUSTER community. He printed it vertically. If you look at the video thumbnail, yeah, you will be amazed with an upcoming hot end video from the Vort guy. Vort guy. Okay, I didn't know this channel. But yeah, looking for the best hot end. Yeah, there is. How to find the best hot end. Is that the video you're talking about? Oh, you said upcoming video. So I guess there's another one coming. But yeah, let's watch this video on Saturday then. But yeah, it's straight into what we were talking about. So would be interesting. Yes, we need to watch that. Yeah, okay, let's watch that on Saturday. Okay, so that was a little bit about the calibration flower. So let me drop a link in the description for you. So if you are interested, it's £5, which is what? What is £5? So maybe Zombie has the price. Yeah, $6. So it's $6 for the software that is going to make the calculation for you, for the STL, and most likely you will have access to a more accurate guide. So let me share that in the. There you go, and it's for it's from Vector 3D, and it looks like he has a shop also. Definitely someone that we need to support. Like I said, he seems to know his stuff. I mean, he you need to spend time understanding a concept if you want to design something for that concept. So he definitely spent a lot of time on calibration, and he's involved in the community with his Discord. So yeah, I just dropped the link in the description. It's $6. It supports someone, very smart guy that is trying to pushing the 3D printing forward, bringing more knowledge to the 3D printing community. So definitely a good purchase. Okay, the next one, let's do that quickly. It's already been 2 hours we spent on calibration flower. Nick, I'm loving the new Cospi. You like the name, huh? Both versions are so easy to send. Hoping to drop a few more videos this weekend with some other parts and different sending options. Oh, great. Perfect. There were some people asking about the different sending way, whether a belt sender was okay with this formula, whether wet sending or hand sending or vibration sending. I mean, I don't know this stuff. That's why I ask you guys, because you are much more knowledgeable about that. But I will send you a questionnaire to everyone. I will send a questionnaire about that new product, and then most likely in 1 week, I still leave 1 week for people to try, and then you can fill out the questionnaire, and then we will move the discussion to Discord, and then depending on what you guys will choose, which formula you will choose, then we will release that formula. But thank you again for joining our beta testing and spending time testing our filament. I sent a message in the Discord posting the video in the video description too. On our Discord. Okay, great. 3D HP, thank you for coming. I'll be honest, I print these things now as a general filament test, and they work as a coaster. Yeah, that's a good point. From what I have seen from other folks, you can do it. It's so easy to send that I just do it by hand. Oh, great! Very good, very good, very good. It was designed for that, and I'm looking forward to introduce this new technology that we implemented in our filament to make it sendable. Anyway, so this is the Bible from Master Ellis from the Voron community that is explaining about calibrating your printer. So let's have a quick look on what it is about. What I can say already is it's pretty impressive parts here. Very nice. But okay. So extrusion multiplier, calibrating your extruder, ensure that the extrusion multiplier will be the same across all printer. Well, you should calibrate your extruder. So let's go there. So you should calibrate your extruder first. Calibrating your extruder ensures that the extrusion multiplier will be the same across all printers. Calibrating your extruder ensure that the extrusion multiplier will be the same across printers. Oh, okay. So if you use an extrusion multiplier in a slicer and you want to print the model in another printer, then you keep the extrusion multiplier, okay? Extruder calibration simply ensures that 100 millimeter requested equal 100 millimeter extruded. Extrusion multiplier is per filament setting, depending on the properties of each material. Oh, okay. So it's the good old E-step stuff. Okay. So I guess we will disagree with the same thing that we disagree with, and we will agree with the same thing we agree with. And I think the Voron is using Clipper, right? And the way Clipper do the calibration is also, we already talked about that, right? Initial startup check, blah, 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 verify temperature, verify heater, stepper motor, end stop check, blah, blah. Why he is redirecting to here? Flow? No. Calibration? PID calibration, PID... Oh, extruder calibration. Okay, there you go. Before the first print, make sure that the extruder extrude the correct amount of material with the hot end at temperature. Which temperature? Okay, with the hot end at temperature, make a mark on the filament between the... Oh, yeah, okay, blah, blah, blah. And your extruder between, blah, blah, where measure the distance, the entrance, octoprint, blah, blah. Yeah, it's the... yeah, okay. Is that really the Bible of extrusion? I mean, is exactly the same as all the current common knowledge of extrusion. Blah, 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 blah. Measure wall thickness. Some guides you will find online mention printing a single or two walled object and measuring the thickness with calipers. I simply never have good result with this approach, and different people seems to get sometimes widely different result. The measured width can vary depending on where you measure it and how much pressure you use. Any layer wobble, blah, blah, blah. Yeah, it's true that the wall measuring is not the best way. I agree. My below method is an aesthetic first approach. This method creates a very smooth top surface and additionally can help with layer consistency. Yeah, so it's the kind of guide that asks you to calibrate your flow and then walk through a process that will calibrate your flow again. Am I too negative here, or maybe I'm too negative? Maybe I'm too negative. I'm sorry for that. Okay, so this also result in prints that are of perfectly acceptable tolerances for Voron parts. Voron parts are designed with shrinkage in mind, so it's fine. Don't perfectly match the CAD. Don't drive yourself crazy. blah blah. The thread screws together now. If you need a true to cut, blah 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 blah. Okay, so what's the method? The best method I have found is purely visual and tactile. Oh, I think that's what Zombie use, like top layers or something like this. We will print some 30 by 30 by 3 millimeter cube. Okay. Printing settings, infill 40, blah 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 blah. Okay. Pattern, blah blah. Okay, step. You set up your slicer with print cube with variation of 1 to 2 extrusion multiplier. You can do this by adjusting the setting for each object, save it as blah blah blah, push a slicer, blah blah. Okay. Blah 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 blah. Okay. Print it. Inspect each cube. Once you are nearing the correct extrusion multiplier, the top should feel noticeably smoother. Too much extrusion will feel. Yeah, okay. So that's Zombie's technique. If desire, run the process again with a 0.5. Yeah. Okay. Yeah, that's Zombie's technique. Did you get it from here, Zombie, or I don't know if he's still here. Maybe not. But yeah, that's Zombie's technique. You basically print some first layer, and then when you are happy with the aesthetic of the first layer, then that's it. That's your flow. It's like he said, it's not very technical. It's more aesthetic. Okay, yeah, I wouldn't consider this as the Bible of calibration, but it's one way that is not very known of calibrating your flow, which is using top layers, which is not. I mean, it's a different way. It's not better. It's not worse than other way, but it's for a certain purpose. So if you're looking of having, aesthetic parts without using ironing, for example, then this calibration way is pretty good. So I like it because it's innovative. It's different. It's different way of thinking. It's more visual rather than measuring something. But yeah, nothing new for us because I think Zombie already introduced it this way on Discord. So I thought it would be something new. That's why. What is this? Oh, this test. Yeah, Zombie. That's the one you explained to me last time. I remember. It's perfect for flow calibration, specifically surface flow. Yes. This is the best 3D printing channel in the world. Thank you. If you are talking about Polymaker channel, not the channel that maybe I've shown on stream. It does take effort to set up, so I don't do it much. Yeah, it seems to involve a lot of printing. Yeah. Nick, that solid work stream just ended 53 minutes ago, so don't feel bad for going 2 hours. Oh, really? Okay. I hope he didn't struggle too much with the SolidWorks. I like the how do you call that, the texture that he is doing. And maybe you should, if you are in contact with him, you should tell him Idea Maker also have a texture tool that he may be interested in. 3DHP, I send you a message on Discord. Yeah, I think I saw it. I will get to that as soon as possible. I need to get to bed. Sorry, so tired. Okay, Matt German, thank you for joining again. This is called an elbow cuff. Like, come on, everyone know this is a dab. This is the best method for calibrating flow. Yeah, I know, Zombie, you like that method. Most people calibrate flows by visual, for your information. Oh, really? I thought most people do the calibration cube or the E-step calibration, like that thing about the 100 millimeter mark, and then you extrude 100 millimeter. Or I thought that's how they calibrate the flow. But again, I think it's so mixed up to have all of this. Like, for me, there is no way you can calibrate your flow. Like, you should calibrate your extruder first and then calibrate your extruder. Like, it doesn't make sense for me. I think it's more, because what I don't understand is why you calibrate. So the printer is doing what you're asking, but you need to recalibrate to make your print looks good. So does that mean our slicers are bad? I mean, you are literally calibrating your extruder and pressure advance, and then you do this. So that means our slicer are not good enough, because the slicer is going to tell the printer to do something, and then the printer is already calibrated, so it's going to do what he's asked for. But for some reason, then it's not good enough. So you have to recalibrate on top of that. You have to change the slicer to make your model more better. So that shows a little bit the level of the slicer, right? Which is bad level. If we have to change the slicer setting because it's not, doing the things properly, then for me it's bad. Chairman One swears on mesh, so I don't know how he would feel about Idea Maker. Yeah, maybe he won't like it. Calibration cube is for shrinkage. Yeah, again, my thinking on shrinkage. I still measure wall thickness for 2 walls to be 0.8, then I fine-tune visual. Okay, yeah, maybe we can do a poll. We can do a poll on what people do for calibrating their flow calibration. I did a poll. I think it was about the name. I think I did. What was it? My last poll was what? Oh yeah. Do you say 3D printer filament or 3D printing filament? Yeah, it looks like it's 50-50. But yeah, we can do a poll on what filament use, what people use. Slicer bad, yes. Hot glue gun printing plastic. Yeah, if the slicer doesn't do a good job, then yeah, you have to do an extra step to make your part look good. Teaching Tech calibration page. Does he has is that the common one or is that a new one? Oh yeah, I've seen that one also. Yeah, I also disagree with this one. This is the kind of calibration that asks you to calibrate your E-step and then asks you to calibrate your flow afterwards, which for me is the same. So yeah, I read that one also, but I don't know. It's not accurate enough. They don't go. It's always missing some. I mean, we can have a look, like slicer flow calibration. You see when blah, 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 our E-steps are now correct in the firmware, right? So just starting by this for me is already why would you require to our E-step is now correct in the firmware. So now you extrude the exact amount of filament that you're asking for. Now let's calibrate our flow. Why? Okay, we have exactly the filament we need. Now let's change that. No, doesn't make sense for me. Or at least they have to explain what's the difference between this and this. What's the difference? No, zombie. No, I promise. We are not going to argue this again. Actually, I think we're gonna stop the stream here. Let's not argue some topics that have been argued already. E-step gets your printer mechanically correct, and flow is for different filament. Zenbender, we are not going to start that topic. I think we already spent hours of discussion on that. Let's say your E-step are 200% off, then your retraction will be... Zombie, I thought you said we are not going to argue this again. So why are you starting it? But anyway, I'm just joking. But you can of course go to our Discord. Make sure. Let me put this guy here. Make sure to enter our PRINTBUSTER topics. So if you haven't, you go and customize your server, and then you can enter the PRINTBUSTER topic by clicking here. And then once you are in the PRINTBUSTER topic, then there will be one topic that is called flow calibration. And if you really want to argue again on this, then feel free to go on that Discord, on that channel, and then we can get the discussion going again. Thank you. Come out on PLA. I'm glad you enjoyed this PRINTBUSTERS episode and my amazing drawing skills. Okay, let's draw someone, and then I think we had a good stream. What happened to the individual filament thread on Discord? Yeah, like I said, if you want to enter, they are still there. You see, there is still all the Polymaker product. But if you want to enter, then you have to go in the customize your server, and then you can choose which one you want to enter. Most likely, you won't be interested in PCPBT, I guess, or maybe Polycast. Maybe you are not printing with that, so you can just select the one that you are interested in, and then it will appear again. So we modified a little bit the Discord in order, because we are going to have more products coming very soon. There is much more application, so you can customize what application. Right now we have cosplay, lithopan, custom printers, Nerf blaster, RC cars, planes, boat, drones, tabletop miniatures. We have jewelry, prosthetics, orthotics, and there is much more coming. So instead of having hundreds of channels, then you can just select your application and stuff. And the good thing is, when you click on someone, then you can know if he's a Polymaker user or not. You can know what printer he has, like Creality, Anycubic, and other printer, and what filament he is interested in. Which is interesting here, that is, he's interested in poly support for PLA. And then what application, tabletop miniatures, and then where he come from, the United States. So the US. So if you have customize your server and about you, if it's filled in, then it's very easy to communicate with people, and then to have your customer server. Anyway, I will talk more about it on Saturday, on why we made that change, and why we believe in the long term it makes a little bit more sense. What's a good filament for cosplay? Well, that's going to be one just for that very soon. No, the giveaway channel is also here, but you have to be level 2 or more to access this channel. Okay, weeklies for level 2. Yes, Kevin Tucker, exactly. Thank you for highlighting that. So we're going to draw in 5, 3, 4, 2, 1, draw. And I realized that Mark and Draka and Builders Mark are not there. So you guys have a fair chance of winning. Nick, congratulations. Thanks all the Mark that are not here, so that you can win the filament. So I need to talk more. Yeah, maybe, I don't know. Oh, Mark U of you was here. So you're very lucky, Nick, if you are still there. But it seems... Yeah, you're there. Congratulations, Nick. Awesome name you have, by the way. And do they get a free roll of PLA or any filament they want? Any filament they want. Can they get carbon fiber? Yes, they can. Congratulations again, Nick. Please send me, I don't know if it's the first time you win or not, but please send me an email there, or just contact me on Discord, and then you will receive a link. So, oh, Mark and Draka was here. So the Mark team has decided to leave the place a little bit, the giveaway for other people. Very nice of you, Mark's team. Thank you very much. Okay, great. So thank you again, everyone, for joining today's stream. It was a lot of fun. I really like going, taking a project, taking an idea, and really dive into that, do some research, Google some stuff. Having some kind of discussion with the chat, and then challenging a few points. That's what PRINTBUSTERS is about. And hopefully, let's keep a smile on our face. Let's be good guy. I really don't want to scare away companies from coming to PRINTBUSTERS to present their product just because we are asking too much questions. So let's always be very open-minded. Okay, let's not be too scary. Otherwise, we won't have enough people here. When will you want to have open chat on the Discord? Maybe this weekend, if you're maybe Sunday. The weekend is where I'm the most free, and maybe we can rediscuss a little bit this Califlower, and because I know you have the most experience, I think, in the chat on that. Okay, thank you everyone, and then I will see you on Saturday for the Polymaker Academy, or next Tuesday for the Q&A, or next week for another episode of PRINTBUSTERS. Have a good one, everyone.